In this lesson, we will cover the basics of schedule network diagram, critical path, total float, and free float. Let's get started. I will use this example to explain the fundamentals. This project has 7 activities. The project starts with activity A. It has no predecessors. The duration of activity A is 2 days. Activity B and activity D can start only after activity A is finished. This means activity A is the predecessor of both activity B and activity D. Activity B takes 3 days to complete and activity D takes 1 day to complete. Predecessor of activity E is activity D. Duration is 1 day. For activity F, predecessor is activity E and duration is 4 days. Both B and E are predecessors of activity C. Duration of C is 8 days. Similarly, for G, predecessors are activity C and activity F. Duration is 3 days. A table is definitely easier to understand, but we still have another better approach: schedule network diagram. We will use the precedence diagramming method, a popular technique to draw the network diagram. The project starts. The first activity is A. It is followed by B and D. After D is finished, we have E. Activity F comes after activity E. Activity C has 2 predecessors, B and E. G starts after C and F are finished. The project is finished when G is completed. Precedence Diagramming Method, or PDM, is also known as activity on node. Here, each activity is a node, and these nodes or activities are connected through arrows. Here is one of the commonly used representations of a node. Not just the activity name, but other activity attributes such as activity duration, early start, early finish, late start, late finish, and total float are also captured in this format. Early start and late start, early finish and late finish. Why do we have these multiple starts and finish dates for an activity? Let me explain. If we go back to our example, the network diagram clearly shows the relationship between activities. Activities that are interrelated. Due to interdependencies, some activities might have flexibility in schedule. Instead of a fixed start date, there can be a range of possible start dates, with no impact on project start, project finish, or any other key milestone. Early start is the earliest an activity can start, and late start is the latest an activity can start. Early finish corresponds to early start and is the earliest an activity can finish. Similarly, late finish corresponds to late start and is the latest an activity can finish. This range of possible starts is the flexibility in the schedule, represented as total float. Total float is the amount of time an activity can be delayed from its early start date without delaying the project finish date. Mathematically, total float equals late start minus the early start. Next, let's understand the relationship between the start and finish of an activity. We have an activity that starts on day 2 and has a duration of 5 days. We work on day 2, day 3, day 4, day 5, and day 6. The activity finishes on day 6. Finish is simply start plus duration minus 1. Start is on day 2. Duration is 5 days. As expected, we get 6. Using this, early finish equals early start plus duration minus 1. Similarly, late finish is. From these two formulas, it is clear that late finish minus early finish equals late start minus early start. So, we can find the total float either as late start minus early start or late finish minus early finish. Let's go back to our example and draw the network diagram again with this detailed representation of the nodes. The project starts and the first activity is A. Duration of A is 2 days. We continue with B, C, D, E, F, and G till we reach the end of the project. To find the remaining attributes, we shall first apply a technique called the forward pass. Forward pass is the analysis of the network diagram from project start to project finish, from left to the right. When the project starts, A is the first activity. Obviously, the earliest it can start is on day 1. Early start for A is 1. It has a duration of 2 days. Clearly, early finish will be on day 2. Early finish can also be calculated using this formula. Early finish of A is early start of A plus duration of A minus 1. 1 plus 2 minus 1 is 2. Early finish of A is 2. Moving forward to activity B. B can start only after A is finished. Early finish for A is on day 2. This means the earliest activity B can start is on the next day after day 2, that is day 3. The early start of an activity is simply the early finish of the predecessor plus 1. Early start of B equals early finish of A plus 1. 3 is the early start of B. Next, early finish of B. It will be early start of B plus the duration of B minus 1 or 5. Similarly, we can find the early start and early finish of D, E and F. What about C? It has two predecessors, B and E. Considering B, the early start for C is 6. Considering E, the early start for C is 5. Which one should we pick? The choice with the highest value, that is 6. We can't pick 5, as C is not allowed to start before the completion of activity B. The earliest activity C can start is on day 6. The rule is simple. Always pick the choice with the highest value. We can find the early finish of C as before. It is day 13. Finally, for G, we have an early start of 14 and early finish of 16. We are done with the forward pass. We now have the early start and early finish of activities. Next, we will apply backward pass, analysis of the network diagram from finish to the start of the project, from right to the left. Starting with G, the last activity, the late finish will be equal to the early finish. Day 16 is the late finish of G. Moving backward, we can calculate late start of G using this formula. Late start of G is late finish of G minus duration of G plus 1. Late start of G is 14. The late finish of an activity is late start of the successor minus 1. Moving to C, it has to finish before G starts. So, the late finish of C is the late start of G minus 1. We have 13. Late start of C can be calculated as 6. Similarly, for F, late finish is on day 13 and late start is on day 10. For E, we have two successors, C and F. Considering C, the late finish of E should be 6 minus 1 or 5. Considering F, the late finish of E is 10 minus 1, that is 9. We should always pick the choice with the lowest value. The late finish of E is on day 5. This ensures that E is finished before the late start of both the successor activities, C and F. We continue backwards with D, B and A till we reach the start of the project. We are done with the backward pass. Let's calculate the total float now. It is late start minus early start. Therefore, for A, the total float is 1 minus 1 or 0. Similarly, for other activities, total float is Notice that for all activities on path A, B, C, G, the total float is 0. Zero float means no flexibility in schedule. This path is the critical path. Delay in early start of any of the activities on this path will cause delay in the project completion date. In other words, this path represents the shortest possible time needed to complete the project. We need at least 16 days to complete this project. Let me explain this further. Between start and finish points, we have three different paths: A, B, C, G, A, D, E, C, G, and A, D, E, F, G. Total duration of critical path A, B, C, G is 2 plus 3 plus 8 plus 3. That is 16 days. Similarly, for other paths, duration is the critical path A, B, C, G has the longest duration of 16 days. The path with the longest duration is the critical path. No complex math is needed. Further, there is also a simpler way to find the total float. We will start by calculating the difference or the gap between the total duration of the critical path and the total duration of each of the possible paths. A, B, C, G is the critical path. So, we have 16 minus 16, 0. For A, D, E, C, G, we have 16 minus 15 or 1. Finally, for A, D, E, F, G, the gap is 16 minus 11, that is 5. Let's try to find the total float of activity E. E belongs to two different paths, ABECG with a duration gap of 1 and ADEFG with a gap of 5. The minimum among these two is 1. 1 is the total float of E. Simple. Let's take one final example. Activity F. It belongs to the path ADEFG, for which the gap is 5. The total float of F is 5 days. Finally, let me introduce another important concept, free float. Free float is the time by which the early start of an activity can be delayed without delaying the early start of the successor activities. To understand better, we will consider activity F. Activity F has only one successor, activity G. How much can we delay the early start of F without delaying the early start of G? 5 days is the answer. If the early start of F is delayed by 5 days to day 10, the early finish of F is also delayed by 5 days to day 13. The early start of G remains the same, day 14, the next day after the early finish of F. We cannot delay the early start of F any further. Free float of activity F is 5 days. Mathematically, free float of an activity equals the early start of the successor minus the early finish of the activity under consideration minus 1. There is also an alternative formula. Both will lead to the same results. Next, we will find the free float of activity E. E has two successor activities, activity F and activity C. Considering only F, free float of E is the early start of F minus the early finish of E minus 1. Free float is 0. Similarly, if we consider only activity C, free float of E is 1. We always pick the number with the lowest value. 0 is the free float of activity E. Similarly, we can find the free float of remaining activities. G, being the last activity, will have a free float of 0. Next, we will look at some problems. John is a first-time project manager and needs your help to understand the critical path method. John thinks that each of the following statements is correct, but you disagree. You are sure that only one of these is correct. Which statement will you point out as correct to John? A. The total float of all activities on the critical path is always 0. B. The path with the highest number of activities is the critical path. C. Delay in activities that are not on critical path do not delay the project finish date. D. There can be more than one critical path for a project. Please pause the video and try to find the correct choice. Alright, we have multiple statements, all related to critical path, but only one is correct. Let's start with option A. Is the total float of all activities on the critical path always 0? No, it's not. Critical path activities will always have the least total float. Total float is usually 0, but not always 0. Schedule constraints can result in either positive or negative float. Option A is incorrect. Next, option B. The path with the highest number of activities is the critical path. This is clearly incorrect. Critical path is the path not with the highest number of activities, but the path with the longest duration. The number of activities do not matter. B is incorrect. Moving to C, can we delay the activities that are not on the critical path without delaying the overall project? Yes, we can, but only to the extent allowed by the available total float. This restriction is not mentioned in this option. So, option C is also incorrect. Finally, option D. Indeed, a project can have more than one critical path. It happens when two or more paths have equal duration, which is also the longest. D is our choice. Let's look at another interesting problem. You are working on a project that is composed of 7 activities: A, B, C, D, E, F, and G. There are 3 paths that connect the project start to the project finish. Start A, B, C, D, finish. Start A, E, D, finish. And start A, F, G, C, D, finish. The project sponsor has requested for a reduction of 4 days in the overall project schedule. You are considering the following options. Which one will you choose? A. Reduce the duration of activity B by 4 days. B. Reduce the duration of activity F by 4 days. C. Reduce the duration of activity E by 4 days. D. Reduce the duration of activity D by 4 days. Please pause the video and try to find the correct choice. Alright, let's look at the problem. The project sponsor wants a 4-day reduction in the project schedule. We have 3 paths from start to finish. The total duration of A, B, C, D is 40 days. For A, E, D, duration is 38 days. And for A, F, G, C, D, the total duration is 30 days. A, B, C, D has the longest duration and is the critical path. We need at least 40 days to finish the project. We are expected to reduce it by 4 days to 36 days. We might be tempted to pick option A. Activity B is on the critical path. Reducing B by 4 days will also reduce the critical path by 4 days. No, that's not right. The duration of A, B, C, D is reduced to 36 days, but the duration of path A, E, D is still 38 days. It is now the path with the longest duration. AED is the new critical path. So, we still need a minimum of 38 days to complete the project. Option A is incorrect. Next, let's check option B. If we reduce the duration of activity F by 4 days, the duration of path AFGCD is reduced to 26 days. But the critical path ABCD is still at 40 days. There is no reduction in project schedule. Option B is also incorrect. If we follow option C and reduce the duration of activity E by 4 days, the duration of path AED reduces to 34 days. Critical path ABCD is still 40 days long. There is no change in project schedule. Option C is also incorrect. We are left only with D, and it has to be the correct choice. Still, let's reconfirm. If we reduce the duration of D by 4 days, the duration of all 3 paths gets reduced by 4 days. ABCD is 36 days. AED is 34 days. AFGCD is 26 days. The critical path is still ABCD, but its duration is now 36 days, 4 days less than the original 40 days. D is the correct choice. Let's look at one more problem. Tony is managing a project that involves 7 activities: A, B, C, D, E, F, and G. Activities A, B, D, and G are on the critical path. Activity C is the predecessor of 2 activities, Activity E and Activity F. While analyzing the schedule network diagram, Tony realized that the early start of Activity C can be delayed by 4 days without delaying the early starts of Activity E and Activity F. Which of the following represents this flexibility in the schedule? A. Total float. B. Total slack. C. Free float. D. Lead float. Please pause the video and try to find the right option. Activity C is the predecessor of Activity E and Activity F. We can delay the early start of Activity C by 4 days without delaying the early start of its successor activities, Activity E and Activity F. 4 days is clearly the free float of Activity C. Free float is the time by which the early start of an activity can be delayed without delaying the early start of the successor activities. Option C is the correct choice. Still, for better understanding of the concepts, let's look at the other options too. Total float relates to the overall project schedule, not to the successor activities. It is the time by which the early start of an activity can be delayed without delaying the overall project completion date. Option A is incorrect. Total float and total slack are one and the same. Option B is also incorrect. Finally, lead float is just a made-up term. Option D is incorrect.